Welcome to Spring LIB.
All right, so let's see what we've got here. This is an isosceles trapezoid. The non-parallel legs are AD and BC. That means that AD is congruent to BC, more or less because it's part of an isosceles trapezoid. Now, maybe I'll say it's an isosceles trapezoid given. Either way, that's what I'm going to have. From my setup, it's also given that AE is perpendicular to DE. So AE perpendicular to DE, and there is BE perpendicular to CE, and those are both given. That means angle DEA and angle CEB are right angles. But that's by the definition of right angles. Now that's important because it's setting up a little bit more information for my proof. Now, lastly, we know that angle CDE is congruent to DCE in our givens. That's given. That means I'm looking at an isosceles triangle. That means this side is congruent to this side. DE is congruent to EC. And that's because it's an isosceles triangle, which means I can now say triangle, let me sure I get the same word they use, ADE is congruent to triangle BCE by the hypotenuse leg congruency. Now, that would be the shortest if your instructor and textbook use hypotenuse leg. If they don't, you can do a few extra steps to prove that this angle is congruent to this angle by doing such things as identifying that this angle is congruent over here because it's an isosceles trapezoid. A little bit of arithmetic, that'll get you in there and you can do it. This is the most direct route, however, using hypotenuse leg.